Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the Rixson number L180 top pivot. The L180 is a top pivot only that is not your average top pivot, in the sense that it is a substantially larger top pivot that is used. I mean, it's substantially larger and heavier. I mean, immediately you can see the thickness of the material. It's 3/8 thick, whereas the standard 180 is a 1/4 inch thick. So the L180, L stands for lead, believe it or not. The L180 is used on lead line door applications, or can be used on lead line door applications. It's also used on heavy duty applications in terms of volume, and very heavy doors as well. So a lead line door is probably a low volume use door. How many times would it be used in a hospital on a daily basis? Probably less than 100, maybe. I'm guessing, I don't know, but it's a small number versus the front door of the local 18,000 seat arena that's going to get, orders of magnitude more volume on a monthly basis than the x-ray room. But lead line doors require this for a different reason, not for volume, but because they're outrageously heavy generally. So the L version, what really happens is, if the construction of your lead line door features the lead in the center of the door, and there's more than one way to position the lead, you can have 2 layers underneath the veneer that are half of the thickness each of the total lead requirement. You need to be mindful that your screws don't pierce that at all. But in a single lead door installation, these screw locations are specifically placed to straddle the positioning of the lead. Okay, so that's why those holes are like that. Whereas on a 180, they're certainly staggered like that, but they would pierce through the lead. But then the other reason for an L180 is because of the high volume traffic. So a lead door, or a high volume traffic, or a super heavy door, lead door, or just a generally heavy door, you're going to use an L series, and the L180 is going to be used in the L27 series floor closers. You'll see that as standard equipment. You're also going to see it in the L147 pivot set, which will give you the L180 top pivot and the corresponding bottom pivot. It's also going to be seen in the L117. Now the weight capacity of the L147 offset pivot is 800 pounds. The L117 weight capacity of that offset pivot is an outrageous 1,750 pounds. The L27 weight capacity of the floor closer with the L180 top pivot, that has a weight capacity of 1,500 pounds. So these are obscenely heavy doors that Rixson just has in their standard catalog. And in fact, we've done recently pivot sets with them that are rated for 3,000 pound doors. Anyway, back to the L180. You now know where you're going to use it. You know where you're going to see it. It's super important, and a lot of people just don't want to have to face it. The L180 is generally a stock item. You can generally get this in pretty much all the finishes. 4 1/3 inch thick door. You can understand how the pivot can certainly work on a door that's not 1 3/4 inch. Let's just assume it's thicker than 1 3/4 inch. Let's not even talk about it being on a thinner door. You can understand how you can still maintain the margin from the face of the door to where you'll prep for this, and then just let your door thickness go this way. That's fine. That's not the right way to do it at all, because you really want, in your set, the bottom arm to be sitting under the door, not standing biased to one side of the door over the other. You want it in the center. Also, if it's a lead line door, not that you're going to have a lead line door thicker than 1 3/4 inch, You could, but you really need to have the center of these holes properly mated for the door thickness. And the problem with that is door thicknesses other than 1 3/4 are certainly factory order lead times, is the bottom line. You can go with stock material and not do it correct according to the book, or you can order the material that's proper for the door thickness. 2 1/4 is obviously something that's not unusual in the world of door thicknesses. Now, the L180 is the standard top pivot for the, as I said, the L147, the L117, and the L27. Doors with LED lighting under the skin should use this product. What they're saying is doors with LED lighting under their skin should use this product as well. This would be compatible, they're saying, for an 1 3/4 door if you have the LED construction underneath the veneer. So if your LED, if you needed to retard the transmission of X-ray, that a 1/8 of an inch LED thickness would be specified as the proper thickness of LED, you're going to go with 2 1/16 of an inch sheets underneath the veneer. And Rixson's catalog is telling you this is still the proper one for that. The screw holes are spaced to straddle LED in the middle of the door as well, as we just discussed. Available to accommodate LED door thicknesses of 1 3/4, 2 inch, 2 1/4, 2 1/2, or 3 inch. Specify that when ordering. Available for fire-rated door assemblies as the FL180, so you can have a fire door and you can use a heavy-duty offset pivot. It would be the FL180. If you need and that's important because this is going to be certainly made only of steel at that point, or stainless steel. It could be made of. I don't know if they'll offer it in stainless, but those are the two base materials. 20-min is also available. A non-ferrous base material. So what they're saying is this out of the box is going to be brass, non-ferrous. If you're going to be doing something fire-rated, those are certainly going to be a ferrous-based material or stainless steel. This is a 3/4 inch offset top pivot. That is basically, there's two offsets, 3/4 and 1.5 inch. Simply this. From the face of the door, when you're standing on the pull side of the door, the face of the door to the center line of the pivot is 3/4 inch. That's important because you may have some trim work that's out here that you need to be sure that you're going to clear. You might have excessively thick trim where you need an 1.5 inch offset. Getting into an 1.5 inch offset, I don't think you're going to find that in an L series at all. Scrolling through their catalog to see what they do in an 1.5 inch offset. Forgive me. Yeah, definitely not going to give you anything with that sort of weight rating at all. Let's take a look. The Rixson 117 can be done with an 1.5 inch offset, which is rated for 300 pounds when you are using a 3/4 offset 117. But when you go to 1.5 inch offset, that weight rating is listed for 150 pound doors, so substantially reduced. There's also then the 147, which can be done as 1.5 inch, the non-L version that would get you a door up to 350 pounds. And that's where this apparently is going to stop in terms of weight rating. Now, back to the L180. 3/4 inch only offset, furnished with wood and machine screws. Yes, we're good to go. Wood and machine screws. And then available with longer than standard pivot pins. Increments are 1/4 inch, 1/2 inch, and 3/4 inch only, meaning the length of this pin you can have longer. You are going to probably want something longer in the event that you have an unusually tall door like an 8-foot door, I would definitely be ordering a longer pin, because I have noticed over time a settling of, or a movement of the frame where this otherwise nice 1/8 of an inch gap between the two leaves when it's installed becomes a 1/4 inch. Well, there's really not that much pin holding that all together. And while you have intermediate pivots, the door is probably not going to fall out of the opening. You know, that's 7/16. Not a lot holding that in there. You've got the weight of the door not hanging on the top pivot, but certainly, you know, its weight, the door obviously wants to fall, would be there. Would not be a good idea to have that. There are times, and because I'm not in California, I understand that California building code will require a longer top pin on pivots because of their propensity for earthquakes. That rectangular door frame is now a parallelogram. You're going to need a longer top pin. Absolutely. And I would use it in those instances where you had something that was obscenely heavy, that you might have an unusual weather event, even here in southern Florida, a hurricane, obviously. Longer top pins, if it's an exterior application, I would really be tempted to go with a longer top pin. If it's a low volume x-ray door in a hospital, and that's not low volume, but it's not the front of the 18,000 seat stadium, and it's probably in that hospital on a welded 14 gauge hollow metal frame, okay, not an aluminum storefront frame. That, in my opinion, is not the proper material to attach heavy hardware to, because just long term it's not going to last like a welded 14 gauge steel frame. I would be very tempted to consider a longer top pin. It does add to the cost, adds to the lead time, but nonetheless you have to engineer it correctly. Now, there are dimensional properties in the template that is included with your paperwork, along with installation instructions. The installation instructions are relatively new, at least as far as I'm concerned. It used to only be the template, which, in my opinion, you didn't need really anything else to install it, because it gives you all of the dimensional properties in terms of where to install everything. So, and I've mortised for pivot hardware, you know, countless times. It's easy to do. You just have to follow the dimensional properties of this. And obviously when you're mortising a door for pivot hardware, the most crucial thing is that your plumb, that where that top pivot is prepped according to the template, and you drop your plumb line, that's where you're going to put the bottom pivot. That's obviously the most crucial thing. After that, what's very crucial is that the net door height in relationship to the overall machining of the top of the bottom pivot, really, your inside frame opening height are all compatible. There's no vertical adjustment on pivots, is what I'm trying to say. There's no vertical adjustment. Can you in your mind imagine how you could pad the bottom of that pivot? Yeah, but if you've got intermediate pivots, you know, and you've got two plates that are designed to be only a specific distance away from each other, you don't have any movement there. Everything's got to be just correct. Not exact, just correct. But it does need to be exact. So immediately you can identify this heavy-duty pivot by not only its 4 1/4 length, which is not so strange, but those big staggered holes. So 4 1/4 length, the A dimension, which on an 1 3/4 thick door is 1 1/4. There's a table down below in the lower right-hand corner of this template, which is linked to in our website as well, called template. You will be able to review how the width of the pivot, how this dimension is going to change as that door thickness changes. Okay, and interestingly enough, they also give you a table of the maximum lead thickness that can be used, and I've got to think that's going to be related to the location of the screw holes. I would think that some math has been done to project the overall weight of the lead. I'm not sure what a square foot of 3/4 inch lead would weigh. I couldn't help myself but look it up. 3/4 inch lead, and I'm pulling that from the table if you had a 3-inch thick door. 3/4 inch lead weighs 46 pounds per square foot. So if you had a 3070 door, that's 21 square feet. The weight of that lead is 1,000 pounds. So I'm sure that they have done science on or math on making sure that the positioning of the screw holes is compatible, but then the maximum potential overall weight that you could throw at the door would be within the engineered purposes of the L180. The L180 doesn't necessarily have a weight rating because it's the bottom pivot that's doing all the work, but as we discussed earlier, the L27 is capable of, what was it, 1,500 pounds. The L147 was 1,750, or the L117 was 1,750. The other was compatible. I don't recall the weight, but the fact of the matter is that table is important because it reinforces the fact that you really need to order the right pivot for the right door thickness, because of how you're going to position the weight of the door over the bottom pivot, and then also for the top, straddle those screw holes out to not pierce any of the lead. So all of the dimensional properties that are there you can easily review. And we won't beleaguer all of those points. We've done the length and the width. You can see from the drawing that they're looking for a 1/16 of an inch between the two leaf plates. Okay. The important aspect of this is obviously making sure that you are 3/4 inch from the face of the door to the vertical center line, 3/4 from the face of the door to the vertical center line, that you are the correct dimension off of the edge of the door, which, looking at this template, is not immediately shown. Let me study. After you study it for a moment, all the dimensions start to fall in line. What they're giving us is a dimension of 7/16 of an inch from the edge of the door to the center of this first hole. Then from there, you can gather that you're going to be working with 5/16 of an inch from the high side of the door to the edge of the prep. Because we've got a 3/4 inch dimension from the high side of the door to the center line of the vertical axis of pivoting, and when you deduct that 7/16, you're going to be at 5/16. So now you know how far over to put it from the edge of the door. You know how far your B dimension that's there, the B dimension on this 1 3/4 door is 1/4 inch. You now know that it kind of looks like a rectangle. The thickness is given at 3/8, and then you simply have to follow the rest of the template to give yourself the balance of how you're going to prep the unit when referring to this curved aspect to the installation. So 1 5/8 over to the center, a 3/8 radius is what they're looking for here, and you're just going to gracefully make that work. You know, at the end of the day, if you've got the hardware in your shop, you can obviously trace it for a reality check, you know, and then know exactly what you're dealing with. So mortising for pivot hardware is generally very easy once you've digested all of the overwhelming amount of dimensional properties on the item. And I always put a caliper on the hardware before machining it. I always do. There are hardly ever variances between the published template and the actual hardware. Hardly ever. Not never. So you got to check it, because whose mistake is it going to be if it's wrong and you're machining it? Well, the manufacturer for having a typo? Not really. At least, anyway, you see the point. So mortising for the top pivot is actually quite easy. It's just a modified rectangle, a certain thickness, placed in a particular in a particular position. The other important item that's here, and they reference it twice, is the 3/16 of an inch radius on that heel edge of the door, because if you're gonna have a hard corner trying to clear the stop of the frame, you're gonna have to break that. Now, I've never put a 3/16 radius on it, because I find that that's really not necessary in the shop when the door is brand new. But I could tell you this, over time, with usage on the door, a 3/16 radius on that inside corner of the door is going to be necessary, because as the door, if this is the heel edge of the door, as the door closes, that outside edge can start to make contact with the stop of the frame. I was just on a job 2 days ago, literally, where we had 3080 doors hung on probably either 20, 25s, or 27 closers. I didn't pull the plate off to look at the closer body. But the problem was they installed an automatic door operator on the active leaf. Not a problem. A pivot conversion was put on the spindle stud of the floor closer so as to give you a ball bearing action. You've bypassed the hydraulic assembly and operation of the floor closer. But over time, well, what happened was the doors may not have been manufactured properly. I would have, on a pair of 3080s, made those doors of structural composite lumber, meaning I've got the best quality material to machine to that's continuous through the door. I believe these doors were made with a standard bottom rail, top rail style construction, that the big bottom arm from that floor closer, or the pivot conversion, was mortised in such a way that the majority of the lumber of that bottom rail is now gone, allowed it to move, and sure enough, that heel edge of that door was just hitting the blade stop of the aluminum frame. Again, not a great product to use because it's just all screwed together, and screws come loose. You're not having the advantage of it all being welded, and there was never any relief made on the edge of that door, so it was making contact even on the other door that was still healthy. There was no room at all for the edge to not make contact with the stop of the frame. In this case, again, a blade stop. So that 3/16, put that on there, because the factory knows in time you're going to need that breathing room, is the bottom line. I've never personally experienced it where that was a problem, but I've witnessed it out in the field that that's a problem. The installation instructions call for that. And what they do on the other side is they really just take all of this and kind of distill it down. And that's important. They give you that 3/4 inch dimension. They tell you how far to put it over from the jamb. 13/16 is what they're telling you to do. You're going to verify that with the other information. These pivots are completely non-handed. You can remove the pivot cap and literally turn, or the spindle, place it in the other piece. You can literally turn this over and move it to where you want it to be. Obviously, you're going to want this to be in the header, is the bottom line. So, is this client going to have to reverse this? I would say you've got a 51% chance that you're going to have to replace it or turn it over. Left-hand reverse or right-hand door seem to be more common, right? Correct. So there's a note: important, use plumb line to make sure that the center line of the top pivot pin lines up with the center line of the bottom. Cardinal rule, absolute cardinal rule. Then they're defining for you in the fourth illustration here the hand of the door. It's very simple in that regard, and you do need to have your pivot set up correctly. But at the end of the day, it's a top pivot, and it's really no more complicated than that. I have machined for these countless times, and I find them to be an incredibly elegant way to hang a door. If you have heavy doors, I would even argue when you hit the 200-pound range, I would really start to consider pivots over hinges. You can go with 5-inch tall hinges that are heavyweight, 4.5 wide for 1 3/4 doors, and that's going to easily handle a 200-pound door. That'll handle it all day long. The problem with it is, though, even if you went with, let's say, a 350-pound door, and we're using 6-inch tall hinges that were 210 thousandths thick, and there were 4 of them on the door. The problem is, as I have been taught, 70% of the door weight is hanging on the top hinge. That middle hinge is doing not much of the work. The bottom hinge, he's just showed up for the party because he heard there was free beer. He's not doing any work. So you get into the heavier stuff, stop thinking hinges, because I've sold knockdown door frames to guys with 1/16 of an inch lead line doors that were 240 pounds or whatever it was, and he just wants hinges. It's a recipe for disaster, whether it's lead or just super heavy or high volume. Okay, pivots are elegant ways to solve these problems, and hinges have a hard stop, just like surface-mounted door closers really have a hard stop at about 225 pounds, because you would need to set the spring tension so high to control the door. Well, the problem with that is you want to be able to close the door. You got to have a lot of spring tension, but then the force required to push the door open is the same. So if you want to reduce that, well, then you reduce your closing pressure. So having hardware designed for what you're actually using it on and in the environment in which you're using it with is crucial, and that's where pivots really come in. That's where they pick up where hinges and other hanging devices really leave off. And Rixson's name, of course, is thoroughly synonymous in the world of pivots. I mean, the name, I think, synonymous with it, and many other good quality products. I've worked with their technical support department on a variety of things I've had to call them for, and they're incredibly helpful, incredibly accommodating, and the different people in the years that I've spoken to have all been the same, incredibly helpful, incredibly accommodating folks, and I think it's why Rixson is a name that is not only ubiquitous and within the industry for pivot hardware and other things, floor closers obviously, but a name that's recognized and a name that people are familiar with, and it's because they back it up with the intellectual goods to go along with the high quality material that's being done. Finally, if you have any questions on the Rixson L180, there is a link below this video to the manufacturer's page where you can pull up not only all of the Rixson products that we sell, but also a link to the manufacturer's website, as well as a link to several encyclopedic documents that are there. It's the repository of important stuff. I happen to know that there's a vintage catalog of Rixson from about 1920 on that page that I've been able to come up with and scan. A neat little walkthrough. I've seen hardware from Rixson. We have been a part of a process of rebuilding a closer from just after the turn of the century, the 20th century, the 19th century turning into the 20th century. We had a client send us one that was from about 1904. So you're going to spend a ton of money up front on Rixson products when you're hanging heavy, high-value doors. But 100 years later, they're still working. Anyway, any questions on the L180 or any other Rixson product, please feel free to reach out to us. And thank you.